To simplify square roots, you need to know some of the basic perfect squares. I'm going to write down some of the basic ones that you need to know. The square root of 4 is 2 because I can write the square root of 4 as the square root of 2 times 2 because 2 times 2 is 4. And then for every repetition of 2's, 1 pops out of the radical. And by the same reason, we can say that the square root of 9 is 3. And the square root of 100 is 10. So basically, the perfect squares of 2 to 10, these are the easy ones that it's helpful that you can memorize, if you can memorize them. And there are also 2 points that I want to point out here. The number that is under the radical sign, we call it radicand. And the number that goes here, we call it index. So for example, if I have, let's say, 81 here and 3 here, 81 is the radicand and 3 is the index. And there are 2 important properties of radicals that we're going to use in this video. One of them is when I have square root of a and a times b, I can break this radical to 2 separate radicals, radical a times radical b, and that's where a and b are both positive. And the other one is that when a is divided by b, again we can break this radical to 2 separate radicals, where a and b are both positive. To simplify a radical means to rewrite the radical with another expression that has the same value. There are 4 steps that you can follow so that it's easier for you. Step 1, you can divide the radicand, which is the number under the radical sign, by the largest perfect square. And in this division, there should be no remainders or no decimals in your answer. And then in step 2, you can rewrite the radicand as the product of the perfect square and your answer, and the answer of the division in the first step. And then in part 3, you can separate the radicals, you can break down the radical to 2 radicals by the property that I showed you earlier. And then in step 4, you can reduce the perfect square or any other reducible term. Notice that you can have more than 1 perfect square when you are simplifying a radical. Let's go over some examples here. For example, rad 50. I know that in step 1, I'm going to divide the radicand, which is 50 here, to the largest perfect square. I know that 50 goes to 25 2 times. So here I'm dividing 50 by 25, which is a perfect square, and I get 2. So I'm going to rewrite the radical as the product of the perfect square and the answer of a division. So that would be rad 25 times 2. And then in step 3, I'm going to separate the radicals. So I have 1 radical here, but I'm going to break it down to 2 separate radicals. And rad 25 is a perfect square, so I can write it as 5, and then rad 2 cannot be simplified anymore. So this is for this example. And 180, rad 180. I know that 180, I'm going to divide it here. Let's actually write it there. I can divide 180 by 9, and I get 20. So I'm going to write it as 9 times 20. But I know that 20 also goes to 4 5 times, and 4 is a perfect square. So we're still in step 1. So I can write this as 9 times 4 times 5. And then I'm going to separate the radicals. So I have rad 9 times rad 4 times rad 5. So rad 9 is 3, rad 4 is 2, and then rad 5 cannot be simplified anymore. So 3 times 2 is 6, so I have 6 rad 5, and that's how we use those steps. Okay, I just want to show you here that in this example, rad 180, I didn't divide by the largest perfect square. So the largest perfect square that I can divide 180 to is 36. So I can just write it as 36 times 5, and then I know that it's 36, rad 36 times rad 5, and that 36 is a perfect square, which would be 6, and then it's just 6 rad 5. And it's good that I did this here because you can see that if you don't divide by the largest perfect square, it's gonna take you more steps. You still get the right answer, but it's just gonna be more steps. Okay, here I have 2 more examples for you. Let's go over this one first. 7 rad 27. This 7 here means it's 7 times rad 27. So whatever comes out of the radical, leaves the radical, gets multiplied by this 7 here. So 27, which is the radicand, is divisible by 9. And when I divide it by 9, I get 3. So I'm going to write it as 7. I'm going to keep the 7 as it is. And instead of 27, I'm going to write 9 times 3. And then in step 3, I'm going to break down the radical to 2 separate radicals. So that would be 7 rad 9 times rad 3. And then rad 9 is a perfect square, so that would be 3. So I have 7 times 3 rad 3. Rad 3, I cannot simplify it anymore. So 7 times 3 is 21. And then rad 3. Okay, there's here if you look at it, 29 can't be divided by anything evenly. So the only factors of 29 are 29 and 1. So I cannot simplify it anymore. So the answer for this one is just 329. 3 rad 29. It cannot be simplified anymore. Okay, I have one example for you to try, and then you try to do this, and then we'll go over it together. Rad 150. Okay, the largest perfect square that 150 goes to is 25. And when I divide 150 by 25, I get 6. So I'm going to rewrite the radicand as 25 times 6. And then I'm going to break down the radical to 2 separate radicals. That would be rad 25 times rad 6. And then rad 25 is a perfect square, which is 5. And then that would be rad 5 rad 6. Okay, now I'm going to talk about cube roots. For cube roots, notice that when we had the square roots, we don't write the index, which is 2. But for cube roots or any other root, we have to write the index. For simplifying cube roots, you can take out any factor that occurs in 3s, which means you can take out any number that is getting multiplied to itself 3 times. For example, cube root of 8, which is a perfect cube, we can write it as 2 times 2 times 2. 2 is getting multiplied to itself 3 times, and it's a cube root, so I can take out that factor, which is just 2. Same thing for 27. 27 is cube root of 3 times 3 times 3. And 3 is getting multiplied to itself 3 times, so I can just take out one of them. So these are 2 examples of perfect cubes. It's helpful to know some of the basic perfect cubes to simplify cube roots. To simplify cube roots, we're going to have the same exact steps that we had for simplifying the square roots. Just notice that instead of dividing the radicand by the largest perfect square, we're going to divide it by the largest perfect cube. And then we're going to write the radicand as the product of the perfect cube and the answer of a division. And then we're going to separate the radicands, and then we're going to reduce the cube roots. So I have 3 examples for you here. The first one is cube root of 54. Let's go over them together. And I know that 54 goes to 27 2 times. So I can divide 54 by 27, which is a perfect cube root, and get 2. So, so I'm going to rewrite the cube root as then step 3, I'm going to break down the radical. So I have cube root of 27 times cube root of 2. So cube root of 27 is a perfect cube root, and it's 3. So I have 3 times cube root of 2. And I cannot simplify the cube root of 2 anymore. And in the next example, I have 12 times cube root of 40. Notice that this 12 is outside of the radical, and whatever leaves the radical multiplies whatever is already outside the radical. So I'm going to keep the 12 for now. And I know that 40, I can divide 40 by 8, which is a perfect cube, and I get 5. So it's 12 times the cube root of 8 times 5. And then step 3, I'm going to separate the radicals. So it would be 12 times cube root of 8 times cube root of 5. Cube root of 8 is 2. So I have 12 times 2 times cube root of 5. 2 times 12 is 24. So I have 24 cube root of 5. Why don't you try the third example and then we'll go over it together. Cube root of 48. Okay, cube root of 48, I know that 48 I can divide it by 8 and I get 6. 8 is a perfect square. So I'm going to rewrite the cube root with as 8 times 6. And then in step 3, I'm going to break down the radical. So it would be cube root of 8 times cube root of 6. I know that cube root of 8 is a perfect cube, and I can simplify it, and I get